Hey, Mr. J coming at you with a video about Area 51. Just kidding. It's a video about area. Not bad. Um, Area I find to be pretty interesting because it's one of those skills that's really useful. So, sometimes in math class, kids will say to me, Mr. J, what's the point of learning whatever, algebra or something? And, I'll try to give them a couple real world examples, but the truth is sometimes in math class, we learn things that are really just about teaching your mind a certain way to think or tackling a problem a certain way. And that's really the truth. Sometimes we teach you math in school that's really just about building towards something else so that when you get to a higher grade, you can learn a useful mathematical skill. Sometimes in math class, we do teach you things that are very useful, and I think area is one of those things. Anytime you are filling something in, you're really using area. Okay, so when you paint a wall, that's area. When you fill a pool, that's area. When you put grass in your lawn, that's area. When you put bricks on the side of a house, that's area. Can you tell I've been fixing my house up a bit? Okay, um, so area is very important, and it also I really like area because it teaches you about these things called dimensions, okay, which are very important in math and science. So if I was to make a tiny dot, now I know that's not that small. Imagine a tiny dot that had no size to it. It's just like a little, okay, an infinitely small little thing. We would say that has 0 dimensions. Okay, it has no dimension in any direction. Okay, versus a straight line we would say has 1 dimension. Okay, and what we mean is it has, let's say, length. It has a certain amount to it going this way, this dimension, but it doesn't go any other way. Okay, then we get a shape, and I'm going to fill in the inside because that's what we're talking about here. This would be 2-dimensional. Okay, and then finally, I can't obviously actually create something that's 3-dimensional, so I'll just draw a representation of it. But here is a cube, and that has 3 dimensions. Okay, and what we mean by that is an infinitely small little point doesn't have any length or any width. It has no this way, it has no that way. A line has 1 dimension. Okay, it has length, and that's it. It doesn't go the other way. 2-dimension, it has both, let's call this one length, and let's call this one width. It goes both ways. And then 3-dimension, it has, let's say, length. Let's call this one width. And let's call this one height. Okay, so it literally has 3. Now, I'm talking about a real solid, right? Like imagine this is a dice. Something you can hold in your hand has 3 dimensions, okay? Now, some of you might be saying, and you'd be very smart to say this, yo, Mr. J, when you taught us perimeter, let's say this is 4 and this is 3. That means this is 4 and this is 3. So this thing has a perimeter of 4, 8, 11, 14. And let's say that's centimeters. Hold on. It's only 1 dimension, but it's a 2-dimensional shape. How come it doesn't count as 2-dimensional? And the answer is because what you're doing when you find the perimeters, you're basically saying, here's the 4, here's the 3, here's the 4, here's the 3. That's what you're actually creating. You're creating a 1-dimensional line out of the sides of the shape. It's kind of like you can imagine sort of like unfolding it and making that 14 centimeter long line. Okay, and that's why it only counts as 1 dimension. And when you measure something in 1 dimension, like a straight line or the perimeter of a solid, or sorry, of a shape, then you could really, mathematically, you'd be correct to add a little 1 there. And that little 1 represents that you are working in 1 dimension. When we find area, we are going to represent that with a little 2 because we're working in 2 dimensions, okay? And let's do one like that, okay? And then obviously, so this one is going to be 12 centimeters squared, and I'll show you how I got that in a second. But it gets that little 2 to represent that we are working in the 2nd dimension. We're working with 2 dimensions. And when you find the volume of a cube, and let's pretend this ends up being, I don't know, 49 centimeters cubed, it gets a little 3 there to show that you're working in 3 dimensions, okay? So that's why, perimeter does not count as 2-dimensional, even though it's a 2-dimensional shape, because we're not counting all this area in the middle. Hey, there's that word area. We're only counting the lines along the outside. So it's still 1-dimensional, not 2. Okay? So perimeter is still a 1-dimensional measurement, versus area, which is going to be a two-dimensional measurement. So how do we find it? How do we do it? How do we know what it is? Let's build one. So I'm going to build a polygon here, and let's build a rectangle. So let's build a square. So 4 by 4. Yo. Okay, so there's my 4 by 4 square. Okay, and I'm going to put on my measurement tool here and just get those 4s on there to prove that I didn't make it up. Whoops, there's our perimeter. We're not interested in the perimeter right now, but there it is nevertheless. Let's get rid of that. No! Come back. Let's move that. Okay, so there's my 4 by 4 square. Okay, and now its measurement in terms of area is actually also going to be 16. In this case, let's say units squared. This is one of those rare cases where the perimeter and the area actually match, but let's look at why it's 16 units squared, okay? Inside here, you can see the actual squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16. There are 16 actual square units inside here. They are actually 1 unit by 1 unit, and they are actually, despite my terrible drawing, squares. There's one of them, there's a second one, a third one, etc., etc. So when we say unit squared, we're not just saying it because there's a little 2 there and you say squared and that's the law of mathematics. No, you are actually making little squares inside this shape. Okay, how many are we making? Well, we're making 16. Where's my proof? There's 4, 8, 12, 16. Okay, obviously the bigger you go, the more area you're going to have. So let's take this 4 by 4 square and let's change it. So right now we said it has 16 units squared, and we proved that. But if I was to stretch this out, and instead of making it 4 long or 4 high, whatever you want to call it dimension, I made it 8. Well, now we've changed everything. Okay, it's no longer 16 units squared. Let's find out exactly how big it is. And we could again count these up, but it gets kind of repetitive, especially if you have a rectangle that's 473 by 9,622. I don't want to count all those squares, okay? So we can make our life a little bit easier. Instead of making this 8, we could make it 5 and 3. And the reason I picked 5 is because I'm good at 5s. If you're good at 7s, do 7. If you're good at 8s, leave it, okay? So 1, 2, 3, 4, 5. I'm just going to break that into 2 smaller parts. So this becomes 5 by 4, which is 20. And this is 4 by 3, which is 12. So altogether, this becomes 32, wow, 32 units squared. Okay, and there's my proof. But again, the whole point of this is you are literally making square units. Okay, it's easy when the grid's there, I know. And when the grid is not, it's not as easy. So let's get rid of that grid and see what we can come up with. So I'm going to get rid of the grid. No grid. And I'm going to build an imaginary rectangle, and I'm going to say how big the sides are. It's hard because I don't even know if I'm making a real rectangle here. Without the grids, it's very tricky. Let's pretend that was a perfect rectangle, okay? And I'm going to put the measurements on here. And let's say that this side is, I don't know, what do you want to be, 21? 21, and in this case, let's say it's meters. I'm building a big old pool, rectangular pool. So I got 21 meters on one side. And on the other side, let's go with, I don't know, 5 meters, okay? Now, again, the point of area is that you literally build all those little squares. So I would have to draw 21 individual squares going up, right? 1, 2, 3, 4, 5, 6, 7, 8, 21. It's going to take forever. I'm not going to do it. And I'd have to make 5 going this way, which wouldn't actually take that long. But again, I don't want to do it. So instead, I'm going to build bigger chunks. I'm going to say, I'm going to split it about there. Actually, that's not a very good spot. Let's move that over a bit. I'm going to move it over to about there. Okay, and then I'm going to split it also here. The reason why I split it there is because I've turned my 21 into 10, 10, and 1. Okay, and now 10 by 5, I'm just copying the 5 from the other side. So 10 by 5 is 50, 10 by 5 is 50, and 5 by 1 is 5. Okay? And again, there would literally be 50 squares in there, right? 10, 20, 30, 40, 50. And again, 50 squares in here. And in here, there would just be 5 because it's 1 by 5. But there would literally be 50, 100, 105, in this case, meters squared. Because I'm literally making 105, those are terrible, 105 little squares. There'd be 50 of them in this area, 50 of them in this area, and 5 of them over here. Okay, and that's how area works. You're building literally square units. Okay, and by the way, if you ever had a teacher who taught you the array method, some teachers call it the area method because that's kind of what you're building inside the array for multiplication. Okay, so some of you might have realized that I've gone this sort of whole time without telling you the formula, and that's because I sort of hate formulas. I mean, I like them, they're useful, they're practical, but what I'm more interested in is that kids know how they work, okay? But the area of a rectangle, and that includes squares, is length times width, boo-hoo-hoo, okay? Or one dimension times the other dimension. It really doesn't matter what you call them, but it's one dimension, in this case, let's say the 21, times the other dimension, in this case, 5. Okay, that's the reason it works, which is what I'm interested in. It literally builds those square units, but that's the formula. And all the other formulas for area of any shape are trying to make squares. So in grade 6, you will talk about the area of a triangle. And I'm not going to tell the formula right now, but there is a formula. Okay, and the thing that that formula does is it says, hey, what if this was a rectangle and we found its area? That would be really easy because finding the area of rectangles is, you can see, pretty easy. You just take one dimension and multiply the other. As long as you're pretty good at multiplication, and maybe then it's easy, right? There's no trick or there's no sort of magic to it. It's just, that's it. So what if the triangle was a rectangle? Then it would be really easy and we could just fix for it, okay? Even when you get to grade 8 and you find the formula for area of a circle, it too tries to build little squares inside the circle. And what if it was a rectangle or square instead of a circle? Okay, and that's area. I mean, area is all about forcing things into being rectangles because that's easier to find. Okay, let's go over here. I got a couple of problems. Let's do the first one. Find the area of these polygons. So I got 2 polygons here. And the reason I've picked these 2, well, I'm not going to tell you. You'll find out in a minute. So here's this crazy looking polygon. It's 4 this way, 4 this way, 3 this way, 1, 1, and 3. Now, there's sort of 2 ways you could look at this. There's the way I look at it and the way other people look at it. And I'm not saying the way I look at it is right and the other way is wrong. I just mean there's 2 equally good ways. When I look at this, I see what could have been. I say, man, if only that had been part of this polygon, then it would be a 4 by 4 square. And that becomes very easy because 4 by 4 is 16. So what if it was 4 by 4? That would be easy. But it's not because this part doesn't exist. Well, that part's also very easy to find. It's 1 by 1. And 1 by 1 is 1. So if I just take away 1, I'm left with 15 units squared. And that's the answer to this question. Cool. Okay, so that we call composing. Just like a composer takes, saxophone here, drums here, clarinet here, they take all those instruments and they compose their great symphony out of those pieces. That's what I'm doing. I'm taking the existing piece and I'm adding on to it. I'm building on. Okay, and then I got to take it away because it wasn't really there. But what if? Now, here is the other way. And again, equally good way. And we call this one decomposing because you're going to take it apart. Some people see this shape and instead they say, well, there's a rectangle there, which is 3 by 1, which is 3. And there's a rectangle there, which is 3 by 1, which is 3. And there's a rectangle here, which is no longer 4 because I used 1 up here. And this is no longer 4 because I used 1 here, right? And it's become 3 and 1, and this one's become 1 and 3. So now this is 3 by 3, which means it's 9. And guess what? 9 plus 3 is 12. Plus another 3 is 15. Okay, so 2 equally good methods. In our case, for this first question, composing was faster. Decomposing took a little longer, But who cares? Okay, the point of math in school is not to be quick. It's not to be first done. It's not to be the fastest. It's not to get the most done. Because in real life, you never run into a sheet of paper that has 50 area questions on it. It doesn't happen. What happens is you're trying to buy grass for your backyard, and the guy on the phone says, well, what's the area of your backyard? Having the right answer is what matters. Okay? Find a strategy that works for you and use it. Okay, in the second one, let's do composing first. So let's pretend it had this chunk on it. If it did, it would be 8 by 8 square. And 8 times 8 is 64. So this becomes 64 units squared. Okay? If, but it's not. If it was there, how big would this chunk be that doesn't exist? Well, it's 3, which makes sense because this side's 8. This side's 5, so I need to add on 3 more to get to 8. And this is 6 here. I can just copy that 6, or I could say, well, it's 8 on the bottom. This is 2, so I need another 6 to finish my 8. So we're missing 18. Okay? If it was 8 by 8, it would be 64, but it's not. It's missing 18. So then I just have to subtract those 18 that don't actually exist. And 64 take away 18 is what, 46, I think? Yes. Okay, so this shape is 46 units squared. Took a little while, but composing, I like that. I like to compose. Some of you, again, let's try the decomposing. So in this case, this is 6. This little rectangle up here is 6, and the remaining one is no longer 8 tall because we've used 3, which means there's 5 left. And this becomes 8 by 5. Okay, and in an 8 by 5 rectangle, 8 times 5 is 40 units squared. And guess what? 40 plus 6 is 46 units squared. Okay, so composing versus decomposing. If someone tells you one is better, I don't know what their problem is. Sometimes composing is faster. Sometimes decomposing is faster. Neither one is better. The one that is better is the one that you get right more often. The one that you understand better and the one that you can explain better. If I'm writing your math test, I'm not giving you 50 questions of area. I'm going to give you like 2 or 3, and I'm going to ask you to prove how it works. And if all you do is write 46 units squared, and there's nothing drawn in here, there's no composing, there's no decomposing, there's no counting, I'm not giving you the mark. Okay? On to the last question here. This rectangle has an area of 24 square units. I'm going to turn off the grid because it does not match. Okay, obviously this is 1, 2, 3, 4, 5. By 3, this is actually 15 square units. So let's get rid of the grid here. I don't want it. So we're pretending that this is a different size than it actually is. How big might the sides be? So in this is an instance where you need to think about your factors. You need to think what multiplied by what is going to give me 24. Okay, and I mean, why not start at the easiest number that you know goes into 24? The easiest number that goes in any number is 1. So if this was 1 by 24, it would be very, very long, and it would have 24 individual squares, right? 1 by 24. And it would be 24 units squared, but that doesn't match our shape, okay? So if there's no shape here, then this would be a great answer. If it just said our rectangle has an area of 24 square units, what might the lengths of the sides be? You could say 1 by 24, and that would be absolutely beautifully correct. But for this question, it's not correct. It does not match the image. Okay, we don't know how long these are, but they're definitely not 1 and 24. If this is 1, this is maybe 2 or 3. It's not 24. So we go to the next factor, which is 2. Does 2 go into 24? Yeah, it's an even number, and it's 2 times 12. Okay, what would 2 times 12 look like? It would be, too big and 12-ish long. That's terrible, but you get the idea. It does not match either. And this one would look like this, right? And there'd be 24 squares in there. So it's, again, not a match. So let's go to 3. Does 3 go into 24? And maybe this one's a little harder for you. It does. It goes 8 times. But I could think, well, I know 3 times 5 is 15. And then another one would be 18. Another one would be 21. Another one would be 24. Or however you want to find it. I remember being a kid, and I was trying to find, 3 times what? I would just go like 3, 6, 9, 12. I would just write them on the side. 15, 18, 21, 24, and I would say, how many was that? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Thank you. Okay, so 3 times 8. And that would look maybe more like sort of that. No, we're getting a little closer. 3 times 8. I think that might be a candidate, but let's try 4 as well. 4. Does 4 go into 24? Well, I know 4 times 5 is 20, so one more, that would be the 6th one, will give me 24. And that would look like, maybe like that. I think my 3 times 8 is not very great. It would be a little longer, I think. That's my mistake. I think 4 times 6 is even better, right? And that would look something like, oh, yeah, okay, and then 6 this way. I think that's a pretty good, I think that's the best match. Okay, and I could go on and say, does 5 go into 24? No, it doesn't. I know it goes into 25, doesn't go into 24. And 6 we've already accounted for. So those are all potential answers. Those 4 are potential answers to a rectangle with 24 square units. But which one matches this picture best? I would say 4 by 6. And that would be, in my opinion, the best answer. And if I wanted to be someone who gets bonus marks, I could say it could also be 3 by 8 or 2 by 12 or 1 by 24, but none of those match the picture very well. And I should put meters or centimeters, whatever it is. In this case, it was just units. Okay, so that's area. I mean, like perimeter, it's not hard in terms of how do you do it. You just multiply the two sides for a rectangle or a square. It's easy to do that. The trouble comes in when the shapes are not perfectly rectangular, right? Like those polygons that we looked at over here that were not perfectly rectangular. We had to make rectangles. Or obviously maybe the side lengths are not even, like it's not an even 6, it's 6.132 or something, and 4.5. Well then, sometimes the math is difficult because the numbers are difficult, but actually finding the area of something is not that difficult as long as you can do the math. Make sense? Anyways, that's area. It's literally making square units.